Remember, in linear regression, we discussed R square, we discussed adjusted R square, we discussed p-value, we discussed VIF value. Tell me one thing, do you think if I move away from Python to R and build a linear regression line, do you think the R square value will change in R software, or if I go to SAS software? Do you think the R square definition changes, R square formula changes, R square value changes, R square interpretation changes? Do you think adjusted R square, P value, do you think they exactly remain the same, or they change from tool to tool? What do you think? Whether it is Python or R or SAS, does it really matter? If you are a data scientist, the way you interpret these values, the way you use these measures and metrics in linear regression line, do you think they change from tool to tool? No. This is a concept. This is tool agnostic. Tool agnostic means whichever is a tool, whether it is Python, whether it is R, or whether it is SAS, the concepts are tool agnostic. You should not say, I don't know SAS, I don't know R. That doesn't mean like, that means that I don't know, I know only linear regression in Python. That's it. If you're saying I know linear regression only in Python, if you give me linear regression in SAS, I don't know, then you're gone. Yes or no? Don't you think these are tool agnostic? At the end of the day, even in SAS, what changes from Python to R? Tell me, or Python to R to SAS, what changes? From tool to tool, what changes? Is the syntax that changes. Yes or no? Maybe here we wrote y tilde x1 plus x2 plus x3. Maybe somewhere else, maybe x1, x2, x3, comma, y will be written. Who knows? Maybe the code or the code syntax changes. But do you think the concept change? Do you think the concepts they change from tool to tool? No. I want you to be confident here. I want you to tell everyone that Python is the tool that I am using, but I'm very confident even if I have to work on R, I'll just find out what is the function, what is the syntax to create it, because I know the heart of linear regression is in interpreting the output. I should know what is R square. I should know what is adjusted R square. I should know what is P value. I should know what is VIF, how to interpret the VIF value, etc. It doesn't matter. Even if I don't know the coding syntax in R, I'm fine with it. Because all that you need to do is syntax is static, standard syntax. If you just go for the usual documentation, you will get the syntax, you will get the result, then you are through. So what I want to tell you is, do not ever say that I don't know some other tool. I don't know linear regression in SAS. I don't know data cleaning in SAS. I don't know data cleaning in R. I don't know linear regression in R or linear regression in SAS. You should not say like that. Are you with me? You have to be confident. You have enough experience on linear regression. No matter what is the tool, you will be able to handle it. Only syntax changes. It takes hardly 1 hour for you to get acquainted or get used to that syntax. You will be cool after that. Are you with me? Even within Python, there is another package actually. We have used stats models. We have used stats models package. Within Python, there is another package called sklearn, scikit-learn. If you use scikit-learn package instead of using stats model package, again the results will be changed. I mean, results will be same. What changes is simply the syntax. Only syntax changes. So just to give you familiarity with the new package, what I want you to do is, in this session, we will try to use stats models anyway, but we will also get used to sklearn. In future, you should be confidently saying that whether it is stats models package or sklearn package, some other package or some other package, it doesn't really matter. I know what are the important measures and metrics. I can handle it. All that I need to know is what is the new syntax in that new tool. So linear regression, let us do a quick recap. What we will do is we will take this product sales data, we will build a model, but this time we are not going to use stats models. Till now we have used stats models package, but now we are going to introduce a new package called sklearn. Remember, whether you're using that package or this package doesn't matter. The results are tool agnostic, package agnostic. That means they are independent of the tool or the package that you have used, because the formula of R square, everybody has to write the same formula. Maybe internally the way they are calculating or the way they are writing the loops, that may change, but at the end of the day, only syntax is the difference. So here is the syntax for writing the code, right? Building the linear regression model using sklearn package. Import sklearn, from sklearn linear model, import linear regression. Now these are the two important lines while building the model. LR equal to linear regression. This is the configuration. So the moment you say this, y equal to beta naught plus beta 1 x1, beta 2 x2, and so on will be, that skeleton will be formed. Now lr.fit, this is a second line that is important. X variable comma y variable. Here there is a slight difference in this package. This package demands that you first mention the x variable, then only you mention the y variable. If you have several x variables, you write x1 plus x2 plus x3 plus x3, x4, and so on, comma, finally the target variable. What was the syntax earlier in stats models? We used to write formula.api dot fit model dot fit. We used to write y tilde x1 plus x2 plus x3 and so on xk. We used to write like that. Now here the syntax of sklearn, which is a different package here, this syntax, it demands that you write the x variables first and then finally write the y variable. Earlier we used to substitute the value of x, we used to predict the value of y. There is directly a predict function available. Here in this particular example, it's a very simple example. We are trying to predict the target variable buying, so somebody whether they will buy a product or not, using the x variable, which is age. Okay, I think the right way to write it is we usually write the target variable this side. So whether a person will buy a product or not based on age, that is what we want to predict. And when age is 4, based on this model, if you write lr is the model, everything will be stored in this model. Lr dot predict, give the value of age, which is 4, give the value of age 105, then you will get the predicted values. The reason why I haven't used in the previous session is, earlier we used to write model.fit. After that, we used to write model.summary. And then we used to get huge summary. But unfortunately, in this LR, if you use sklearn, there is no summary. That doesn't mean it hasn't calculated anything. Everything is calculated and stored in LR. If you want the coefficients, you have to write LR dot coefficients. If you want the intercept, you have to write lr dot intercept. One by one, you have to write everything. There is no summary. If you want the r square, you have to write lr dot matrix dot something dot r square. Like that, you have to write one by one, one by one. Maybe to create that summary, maybe we have to write 40 or 50 lines of code one by one. Then you will get that complete summary. So there is a good summary in the previous package. I generally prefer that package while working on linear logistic regression line, but both packages are accurate. Now that you know what is required, you can directly use any one of these two packages. But the real reason why I'm introducing this to you is to impart the confidence that no matter what tool you are working in future, it doesn't matter. Regression is a concept. If you are aware of the concept, you should never say that I'm not aware of the tool. Okay, you should always be comfortable, because I cannot really give guarantee that in future you're going to work only on Python. Who knows, maybe a particular team that you are joining in as a data scientist, they might be using something else. They might be using R, they might be using Veka, they might be using SAS, or maybe in future there might be some other language, Google Go language, or you have Julia language. There are so many. Kitna seekhenge bhai? How many languages we'll learn? No, learn one language, perfect topic concepts. Later on you can adopt depending on the team. All that you need to do is just know the basic syntax. You should be able to handle that. All of you open the code file now. Quickly get this data set, open the code file, import this data set, build the model. So lr is the model, this is the intercept and the coefficient. What I want you to do is use this model, tell me the predicted values. When age is 4, what is the predicted value? When age is 105, what is the predicted values? Quickly go ahead, do that, and tell me the results. What are the predicted values? When age is 4, what is the predicted value? When age is 105, what is the predicted value? Quickly tell me that in the chat window. So when we go back and execute it, we will realize that when age is 4, the predicted value I'm receiving in the chat window for age is 4, the predicted value is minus 0.086, right? Right, 6 something like that. And then when age is 105, the predicted value is 2.0285. I think, is that the number everyone is getting? Let me verify. When age is 4, the predicted value is minus 0.0866. That's right. When age is 105, it is 2.02. Do not draw the regression line yet. Do not do anything that I haven't discussed. You will miss the point. Do not go further. Just wait here. Okay. So these are the values that we got.